All right, Dan, what kind of setup do we have here?
Well, I heard that if you move a magnet through a coil of wire, it generates an EMF. If you attach something to it and have a circuit, you can light up a light bulb or something. And so I tried it. It seemed to work, but it was hard to get quantitative results so I could see what affected it. And so what I did is I put a coil around this tube, and I can drop the magnet through, so it'll be going through the coil about the same speed every time. And then I can alter how many loops there are in the coil to see what effect that is too, just by winding the wire around.
Okay, and it looks like that loop is connected to this voltage sensor here.
So the voltage act as a proxy for the EMF generated.
Ah, okay.
And we can measure that using capstone. And so let's give it a try.
All right, so before I start recording data from that voltage sensor, I'm just going to click 0.
Yeah, definitely zero it.
And then also notice the sample rate, the rate that data is being collected is really high, because I think that thing's going to go through pretty quick, right?
Right.
So we're going to record 1,000 data points per second. All right, so are you ready?
Yep.
Click record.
It definitely did something when it went through. Let's expand that, see what that looks like.
Okay, so let me just zoom in here. Oh, look at that. So there's a little bit of a dip down and then a dip up as it goes through, right?
So when it's falling toward the loop, the voltage is measured to be negative, and when it's falling away, positive. That's interesting.
Okay, and I think in this experiment, we're going to want to figure out what the maximum voltage is as it goes through, whether it's negative or positive, and we want the absolute value of that, right?
Yeah, just take the magnitude of it.
The magnitude.
So but these are really, yeah, so it's like 0.02 something. But these are really tiny numbers. It'd probably be a good idea to do multiple trials.
Okay. All right. So
let's drop it, say, 4 times through.
Okay. So
I'm
going to delete this run. This was sort of a test. So I'll just click delete. And then just for good practice, 0. I'll click 0 again.
Okay.
And then I'll click record. Okay. There's 1.
There's 1.
2.
Yeah.
And you're dropping the same end of the magnet first each time, right?
Yeah, I don't have it marked north or south, but I put a little mark just to tell.
Okay, so yeah, so if it was the north, the north end goes in first every time, kind of thing, right?
So there's some variation there. So I think doing multiple trials was a good idea.
Mm-hmm.
So let's read off the maximum and then average them together for each pair.
So it looks like for this one, the setup that we have, the negative spike has a greater magnitude than the positive spike. So I'm just going to go ahead and use that.
So every time?
Yeah. So this one is negative 0.024, but we want the magnitude. So we're just going to use 0.024. Okay. And then the next one is 0.024. And then the next one is 0.023. And then the next one is 0.023.
Okay, so you could probably guess that average. And so it's 0.0235.
Okay,
so I think we have a data table set up for that.
That's right. And so we've got a data table that shows number of loops and whatever the average is that we just calculated. And so for one loop, our average was 0.0235.
Yeah,
right?
that's probably, since it's 5, we'll put that extra place there. So now let's double the loops, and you want to make sure that you turn it in the same direction as the first loop. So it's winding around in this direction. So now I have 2 loops, about the same area each. So I've doubled the area of the loops.
Oh, I see. Because if you took the 2 loops and spread them out to one big loop, that's double the area of one loop.
Yeah.
Okay, I got it.
This will be easier.
So 2 loops now, right?
But we're still dropping it from a same height, 25 centimeters.
Okay. All right. Just let me know when you're ready.
Okay, I'm ready.
Okay, go ahead. We see the spike is noticeably taller.
Good. That means I wound it in the wrong direction.
The right direction.
I mean, right direction. There we go.
All right. And so this one, it looks like the positive spike is the taller of the two, positive versus negative. So I'm going to use my coordinates tool, and I'm just going to show this. We're not actually going to write this down or calculate the average, but we just pop that there, take that value, do it for those 4 runs.
We got to leave them something to do, right?
Yeah.
So your job is to figure out which one of those is the greatest peak for each pair and average the 4 values together for all 4 pairs and enter that in the data table for 2 loops.
Okay.
And so let's do a
3
third loop.
And the loops are, we keep the loops at the same place in the tube.
Right.
For all of these runs, right?
Yeah, kind of sort of averaged around 25 centimeters.
Okay, so 25 centimeters from the top. So
Right.
we're dropping the magnet from 25 centimeters above the
Every
loop.
time, pretty much.
Okay. All right, so now we got 3 loops. I'm going to go ahead and click record, and we're ready. Yep, and this one is taller than the previous. Here's 4. That looks pretty good.
So 3 loops, 4.
All right, you ready?
Ready.
Oops, that went down just a little bit. There we go.
Two. So I have bubble wrap in here because magnets are fragile and we don't want it to get cracked. 4.
There we go. 4 runs. No, excuse me, not 4 runs. 4 drops.
And now for 5 loops.
5 loops.
This will be the last one before we do our analysis, see what's going on here. There we go.
All right. 5 loops. Ready?
Yep.
Oh, do that one again. Go ahead.
Too fast for you.
Yeah, too fast for me. There we go. Yeah, 4.
There we go. And a little variation, so I still think it's a good idea to do multiple trials. Always is.
Okay, so let's take a look at all the runs together just to see how the amplitude's changed. So I click this button here, and then I can turn on all of the previous runs. And you see run 1 is blue, 2 is purple, 3 is this other color here that's shaded a little bit. And you see the successive runs, the spike or the magnitude gets a little bit taller. So as we increase the loops, we got more EMF.
And so you're going to do some analysis with the data and create a graph. And if you see a trend, you should be able to use that trend to predict something. And so in this case, you're going to predict what the voltage would be if we had 8 loops. And so you're going to predict that. And then so you can see how well your prediction went, we will collect the 8 loops, but don't cheat. Don't look at it before you make your prediction. And I think you'll find that your prediction will work out well.
All right, so now we need 8. We're at 5, so we need to wind it 3 more times.
So you want to help me count here?
Sure. So 5.
Make sure we have 5 to start with. 5, 6, 7, 8. Always want to be careful counting.
Make sure you've got 8.
And I put them so their average height anyway is 25 centimeters below the top.
Same as what we use for all the other
again, you're
runs.
going to predict what will happen, and here we're going to collect the actual.
All right.
Ready?
Yep. good. And there we go.
So you use that to test your prediction. So, we were noticing there's a little difference between the reading for the top and bottom. Was there any sort of trend? Is the one where the magnet's going in higher or when it's coming out higher? In other words, the first versus the second.
Yeah, let's take a look at this one right here.
It's such a tiny difference.
Let's take a look at that one there.
So it's just a little bit different. But doing all these, you might notice that the second one is usually higher. And so I was thinking that was because the magnet's going a little bit faster as it's leaving the loop than when it's coming in. But it's really hard to tell. So our next investigation is going to be changing the height of the loop.
Okay, so if you change the height of the loop, you're going to still drop the magnets from the top of the tube.
From the top.
Right? So the distance between the drop and the coil starts off smaller.
Right.
So then it's going to be going a little bit slower when it goes through, right?
So now I have it 5 centimeters from the top. So the magnet will have only fallen a short distance. It'll be going kind of slow compared to from the 25 centimeter.
All right.
And we're also going to title all these runs so you'll be able to tell the ones we already took will say 25 centimeter height and then the number of loops. Now we have 8 loops. And so we'll have 8 loops and say what the height is.
Okay. So let me just to be safe, click 0 here. And we got 8 loops, 5 centimeters. So the magnet's going to drop 5 centimeters.
Yeah. So not very far.
All right. You ready?
Yep.
Good. There we go.
Almost too fast for you. But still definitely a spike.
Yeah.
Even though it's going a lot slower.
Yep. There's 4. And so you mentioned a second ago that one spike has a lower magnitude than the other. And you see here the negative spike goes down just past about 0.05. And this one goes about halfway in between 0.05 and 0.1.
So that difference in speed shows up more here than down at 25. Yeah. So let's bring it to 10. So we're going to double it.
Doubling the
So
distance.
You might wonder what happens if you double the height. Is it going to make it more or less? And if so, by what factor?
Okay. You ready?
Yep.
Go ahead.
Definitely more.
Mm-hmm.
Doesn't look twice as much, though.
Yeah.
So you may have to explain that as part of the lab. And so even though you're learning about electromagnetism, you may have to do a little kinematics review to see what's going on there.
All right. So
but maybe it's just because it's so small. Let's bring it up to, let's double it again. Let's bring it up to 20.
Okay, so now you're dropping it from 20 centimeters above the coil. So it's going to free fall for 20 centimeters.
Yeah, pretty much. There's a little friction, but it's pretty much free fall.
Okay. All right, you ready?
Yep.
Let me turn these off. They're not gone. I just hid them so we don't see them. All right. 20 centimeters.
And the last one.
Okay.
So you're not going to do a graph with this data, but you are going to get the average peak voltage from each pair of those spikes, and then see if you can figure out what's going on with the effect of height, which is also sort of the effect of the speed of the magnet as it goes through.
Okay, great.
Good luck.